For basically all of human history, we've stared up at the stars and asked this one huge question: are we alone? But what's so incredible is that today, that question is moving out of philosophy and, well, into the world of forensics. We're actually the first generation that has the tools to genuinely investigate it. So let's grab our cosmic magnifying glass, because our investigation starts right now.
And it all kicks off with this beautifully simple question. It was first asked by the physicist Enrico Fermi way back in 1950. He was just looking at the sheer number of stars, the incredible age of the universe, and he realized something just doesn't add up. If life is out there, it should be everywhere by now. So, where is everybody?
And that, right there, is the heart of the mystery we're digging into today. It's called the Fermi Paradox. On one hand, you've got the math, which pretty much screams that the universe should be absolutely teeming with life. And on the other hand, all we hear is silence. And this contradiction is what drives the entire search.
Okay, so to really get why this silence is so strange, we first have to look at all the evidence that suggests the universe should be anything but silent. Because the clues pointing to life, they're quite literally everywhere we look.
So as far as we can tell, life really only needs three basic things. First, you need a liquid, something like water, to get all the chemicals mixing together. You need an energy source, could be sunlight, could be chemical reactions, and finally, you need the right chemical building blocks. So the big question is, are these things hard to find?
Not even close. As the great Carl Sagan famously said, we are made of star stuff. The core elements of life, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, they're some of the most common elements in the entire cosmos. They're forged in the hearts of dying stars and then just scattered across every galaxy. So the bottom line is, we can't blame a lack of ingredients. And what about places for life to live? The real estate? Well, thanks to NASA's Kepler mission, we now have a pretty staggering answer. It turns out that somewhere between 20 and 50%, up to half, of all stars like our Sun probably have an Earth-sized planet in the Goldilocks zone. That's that perfect spot where liquid water could exist. The universe is just packed with potentially habitable worlds.
Which brings us right back to this stark, deeply frustrating reality. The ingredients are common. The kitchens to cook them in, the habitable planets, are abundant. And yet, after all of our searching, the number of confirmed alien life forms remains exactly what you see here. A big, fat zero. This is the heart of the paradox.
So, as any good detective would, let's start our investigation close to home. The most direct way to search for life is to send out our robotic detectives to the prime suspects, right here in our own solar system. And of course, our number one suspect has always been Mars. We know for a fact it used to be a warmer, wetter world. And just recently, the Perseverance rover, digging around in an ancient river delta, found this incredibly tantalizing combination of chemicals. Now here's the kicker. On Earth, this exact cocktail is a known signature of microbial life.
But here's the catch, and it is a huge one. It's totally possible that non-biological, just purely geological processes could have created the exact same signature. This is what scientists call the great ambiguity. Our rovers on Mars can find clues for sure, but they can't make a definitive arrest. We have to bring the samples all the way back to Earth to know for sure.
All right, let's move to our next suspect, Jupiter's moon, Europa. Underneath its thick icy shell, it's hiding a colossal secret. A global, salty, liquid water ocean that has more than twice the amount of water as all of Earth's oceans combined. And because it's being warmed by Jupiter's gravity, it could have hydrothermal vents on its seafloor, just like the ones that support these vibrant ecosystems in Earth's deepest, darkest oceans.
But then we have suspect number 3, which is maybe the most exciting of all: Saturn's tiny moon Enceladus. Get this, it's actively shooting out these massive geysers of water from its own subsurface ocean. The Cassini spacecraft actually flew right through these plumes and tasted them, and what it found was just staggering: water, complex organic molecules, and a chemical energy source, all three ingredients for life. It's basically advertising its own habitability, offering a free sample to the rest of the cosmos.
Now, while we're out investigating our local neighborhood, there's a whole other search happening on a much grander scale. Think of it as the galactic stakeout, where we use these incredibly powerful telescopes to look for signs of life hundreds, even thousands of light years away.
And this massive search is really split into two very different strategies. You've got astrobiology, which is what we've been talking about, looking for any biological sign, think microbes. And then you have SETI, the search for extraterrestrial intelligence. SETI isn't looking for microbes, it's looking for technology. It's basically asking, is anyone out there talking?
So let's stick with the search for biology for a minute. Just look at how fast our tools are getting better. First, back in 2009, Kepler took a census and proved that, yep, planets are super common. Then TESS came along and found us the best nearby targets to study. And now, the James Webb Space Telescope can actually analyze the air of these distant worlds. And looking ahead to the 2040s, the Habitable Worlds Observatory will try to do the unthinkable, take a direct photograph of another living planet.
But even with these unbelievable new tools, we run into a really familiar problem. The JWST recently picked up a hint of a gas called dimethyl sulfide, or DMS, in the atmosphere of a planet called K218b. Now, here on Earth, DMS is only produced by life. So, huge news, right? Well, after more analysis, it turns out the signal wasn't quite solid, and it's possible some weird non-biological chemistry could be making it. It's the exact same ambiguity we found on Mars, just projected across light years of space.
So what do we have? We have clues everywhere we look, from Mars to distant exoplanets, but every single one of them is ambiguous. And the great silence, it remains. So this brings our cosmic detective story to its climax, the two leading theories that try to solve the Fermi Paradox once and for all. Okay, on one side, you've got the great filter. This theory says that there is some evolutionary step that is so impossibly hard to get past that almost no species ever makes it through. Then, on the other side, you have the rare Earth hypothesis. This idea argues that while simple life, like microbes, might be common, the specific, frankly absurd combination of lucky breaks needed for complex life is just astronomically rare. Let's look a little closer at the great filter, because it has two completely, profoundly different outcomes for us. The optimistic view is that the filter is behind us, that maybe the origin of life itself was a 1 in a trillion fluke, and we just happened to win the cosmic lottery. But the pessimistic view is that the filter is still ahead of us, that eventually all intelligent civilizations discover some technology that leads to their own destruction.
And this quote just brilliantly illustrates the chilling logic here. Think about it. If we find simple fossilized microbes on Mars, it proves that the origin of life isn't the filter. It means life starts easily and is common, but the galaxy is still silent. That would be a terrifying clue that the filter is still to come, an unavoidable doom that awaits every single technological species. Finding simple life nearby would actually be a terrible, terrible omen for our own future.
Now, the alternative, the rare Earth hypothesis, is maybe less terrifying, but just as profound. It doesn't say we're doomed, it just says we're special. That to get from a single microbe to a civilization like ours requires this perfect storm of cosmic luck. A huge moon to keep our climate stable, a giant planet like Jupiter to act as a cosmic bodyguard, stable plate tectonics to regulate our atmosphere. The list goes on and on. In this version, the universe could be full of pond scum, but worlds like Earth are exceptionally rare.
So, this is where our investigation stands today. We are living in an age of cosmic ambiguity. Our absolute best instruments are picking up these faint whispers and tantalizing clues in the great cosmic silence, but we have yet to find that one, definitive, unambiguous signal that finally solves the case.
And that leaves us with the ultimate question, doesn't it? When we listen to those silent stars, are we hearing a promise that the cosmos is a vast, open frontier just waiting for us? Or are we hearing a quiet warning, an echo of the fate that awaits any civilization that becomes loud enough to be heard? The search continues.